OK， 来我们继续啊。So 接下来是 resonance 啊。So by now you should know free and force now comes with resonance. So resonance 只是 for force vibration 嘛 ，OK， 只是 for force vibration. Now what is that resonance? For example, we take the same example just now, the pendulum. Okay, pendulum. Now here, so every time it swings up here, okay. So I let it swing from here, this height over here. So H1. Now it swings to the right, and then it swings back. Now the moment it wants to swing to the right, I give it a push. I have to time my push. Okay, so I write down here, meaning that I have to time the push, so that every time when it starts to swing to the right, I give the push. I give the push at that particular instant of time. Okay, so when I time the push exactly, that is exactly the same as the natural frequency of the pendulum, then the resonance will occur. So what happens is that the amplitude will increase tremendously. Okay, amplitude will increase very dramatically. Okay, amplitude will increase in a very great extent. So you can think of this like the playground swing. You can think of this one as the playground swing. You see in the playground swing, right? When we play we pump our legs like in rhythm with the swing, right? 你玩那个秋千的时候呢，以前你每次你 swing 去后面，你伸直你的脚，然后它会 swing 到更远更高，对吗？那个你也是在 time 你的 push， you are timing so that when you swing down, you stretch your leg, right? And then you increase the altitude and the distance. That is also an example of resonance. OK? 所以你不需要很大的 force， 你只需要 timing 刚刚好，你就可以 increase 那个 amplitude. You can increase the height, the distance, as long as your timing is right. You don't need huge force. So same as this concept here. All right. So this swinging pendulum, every time the pendulum swings to the right and then it swings back, the moment it wants to swing to the right, then you give it a push. Okay, the timing is very important. Okay, so if the timing is right, then you give it a small push, then the amplitude of the pendulum will increase dramatically. Okay, so this is something we call resonance. Okay, so it's all about timing. It's all about timing. You don't even need much force. You don't even need much force. Okay, so resonance 是讲着当你给它的 frequency 是 same as its own natural frequency. Okay, so I write down here, it can be like the forced frequency, which means the frequency given by the external force, is the same as the natural frequency. Then you get resonance. Okay, you get resonance. So resonance is the same as amplitude increase. Right, amplitude increase. Now I'll give you another example. Okay, another example. So let's say we have the same example as just now under the tuning fork. The tuning fork. Now I have the first tuning fork. I attach it with a wooden block down here. Let me draw it further. Okay, U-shaped tuning fork. I attach it to a wooden block. Now I have another one, which is exactly the same. Okay, exactly the same, meaning that they have the same natural frequency. Okay, so as I strike it, right, they will vibrate at the same frequency. Okay, this is the first thing you need to know. Both must have the same natural frequency, otherwise it won't work. Both must have the same natural frequency. Now, what happened as I strike the first one? As I strike the first one, the tuning fork vibrates, right? It vibrates. So what happened here is that this vibration will be transferred to the air, correct? Okay, the air surrounded by the air surrounding the tuning fork, they will vibrate. Okay, as the tuning fork vibrates, it will transfer the vibration to the air particles. So the air will vibrate and it will produce sound. Right, that's where sound comes from. It comes from the vibration of particles. Okay, so sound is produced. So this sound will travel and the sound travel and hit another tuning fork. So what happened? This traveling of the sound, they travel in series of compression. OK， 因为在 longitudinal wave 你有学到 compression 跟这个 rarefaction， 对吗 ？OK，sound wave 你看那个 springs， 你有可以看到有 compression， 然后 rarefaction and then compression and rarefaction. So sound wave travels like this. So you have like a series of compression reaching the other tuning fork, right? So the first compression strikes the tuning fork, this one, and this tuning fork will start to vibrate a little bit, just a little bit. Okay. Now, as the second compression strikes, the second compression is the timing is very accurate. Okay, so that it will create a resonance. 就很像我们上面的那个 pendulum. Okay, your push, if your push is very timed, is very accurately timed, then you will create a high amplitude, right? So this one is because of the two tuning fork, they have the same natural frequency, right? So as the first one vibrates, it sends the vibration to the second one, and the vibration, they are in time, they are in tune, right? They are in perfectly tuned, so that the first compression causes the vibration a little bit, and the second compression strikes the second tuning fork, it creates a bigger vibration, right? And then the third compression, the fourth compression, and the following, okay, strikes the tuning fork, and again, it creates overall, it will create a resonance. So you will see that if you take two tuning fork that has the same natural frequency together, as you strike the first one, you will see the second one will start to produce sound. Okay, you see that as soon as the first one vibrates, a few seconds, you will see the second one, they will automatically vibrate. They automatically vibrate and automatically they will produce sound. If you stop the first one, the second one will keep vibrating as if you're striking the second one. Okay, so this is the natural frequency, one example of it. Okay, it's because of the same frequency. The push is perfectly timed, so that it increases the amplitude. Okay, this is why 你看很多那种戏他们用那种声音来 break 那个 glass 那种窗你唱高音然后 break 那个 glass. The opera, all that opera, they sing towards the glass, and the glass breaks. This is also one of the reasons of resonance, because the glass has a certain natural frequency, right? Every object has a natural frequency. So the opera he sings, right? His voice he's able to tune his voice matches the natural frequency of the glass, so that it increases the vibration, and this is why the glass it breaks. Okay, now same as the bridge. Okay, there was an incident back in like 1940. Okay, they call the Tacoma, I think it's the Tacoma Bridge in the US. Okay, the Tacoma Bridge. The Tacoma Bridge in 1940, like just 4 months after they opened for traffic, it collapsed. Okay, why it collapsed is because of the resonance also. Because you have all the bridges, they are exposed to wind blowing, right? Wind blowing from here, wind blowing from there. All the bridges, they are exposed to the wind blow, right? So what happened is that this wind, as it blows the bridge, right, it will shake the bridge, shake a little bit, but we cannot see it, of course, we cannot see it, but it will shake it a little bit. So the bridge will vibrate. Now, what happened is back in the 1940s, this Tacoma Bridge, unfortunately, the wind had the exact same frequency as the natural frequency of the bridge. Okay, so the frequency matches, right? The wind blows like few seconds blow one time and a few seconds blow one time. So that frequency matches the frequency of the bridge. So what happened is that it created a resonance. So the vibration of the bridge is too large, because the resonance increases the amplitude, right? So the bridge vibrates at very high amplitude. So that is why, as a result, it breaks down. Okay, it collapsed. The bridge collapsed. Okay, so this is it looks like a very small, insignificant concept, but it's actually very important. Okay, you see everywhere in your daily lives. Application of the resonance. Same as the guitar. OK， 你玩 guitar， 你 plug 那个 string 的时候是那个 vibration transfer 去那个 guitar 的身体。OK，and then the guitar also vibrate. The body of the guitar also vibrate. And somehow the vibration of the string and the vibration of the guitar body, they matches. Somehow they matches. So that is how you get the sound, the amplified sound, the amplified sound. Otherwise, the sound would be very quiet. Okay, so it amplifies the sound. Okay, it's also because of the resonance. So to prevent, one thing they did after this incident, the Tacoma narrow bridge, the Tacoma bridge, right? One thing they did was they installed the dampeners. All right, so dampeners. So what is dampeners? Dampener is like your car absorber. Okay, as you go through a bump, your car will shake, right? Okay, the shock absorber is like a huge spring. Okay, so they have dampeners installed in the bridge so that it brings down the amplitude. Okay, so the dampeners, it decreases the amplitude. It is used to prevent resonance to occur, So you can see all these if you look at all the bridges, all the very large bridges, you see under the bridge, there will be this one thing, a device. Okay, most probably it is the dampeners. Okay, it's like mounted below the bridge. Okay, so to prevent overshaking. Okay, so it reduces down the amplitude. So if the graph looks like this, let's say this is the normal vibration of the graph, and in wave, right? Every oscillation we can draw it in wave. So this is the wave. What happened with resonance? Okay, let's take the first one. Resonance, it will increase like this. Okay, so the amplitude increases dramatically. So with dampeners, what will happen? If you install a dampener, then the graph looks like this. Okay, not as high, okay, not as tall. It looks like this. Okay, slowly it will like flat out like this. Okay, so it reduces the shock, but it prolongs the response time. Okay, 它 reduce 那 amplitude， 可是它 prolong 那个 response。response 就是比如说 it takes some time to bring it to a stop. Yeah, because you have you can think of it like a car absorber, right? Inside your car, under the wheels, you have this very huge spring, right? As you go through the bump, this spring will bounce, right? Bounce. So it takes some time for it to come to rest, right? The bounce. You have bounce, but it takes some time to come to rest. That is called the response. The response time. So 那个 spring 那个 car absorber 是它 decrease 那个shock. Okay, the shock get from the bump, but it prolongs the response time. Okay, so this is how dampeners. Now, next one I'll talk about damping. Okay, so the damping is also in the next part. Is related to resonance. Okay, now let's look at damping. Okay, for damping, the graph looks like this. 这个是你的 normal 的 wave graph. This is like perfect ideal case for the wave. It always stays the same. The amplitude is always the same. This one is always the same. We can consider this as no energy loss. Okay, it's the ideal case. But in reality, most of the waves, they lose energy, right? They lose energy. So how does the graph look like? The graph looks like this. So at first, the first vibration, the first cycle, they have this amplitude. The second cycle, the amplitude decreases like this. The third cycle decreases even more. Fourth cycle decreases even more. Fifth cycle almost gone like this. So if you compare these two, amplitude, this one decreases, lower, lower, and eventually gone. This is no damping. You can think of it like loss of energy. Loss of energy. This is damping. Sorry, terbalik. No damping means no loss of energy. Okay, damping. This one is loss of energy. Okay, so there 有好有坏啦 damping。Okay， 好的就是for 用 for shock absorber 啦。Okay, shock absorber to prevent resonance. Okay, like in buildings the earthquake to prevent from to prevent the building from falling down, okay, topple, we have to install the dampeners also, just like in bridges. Okay, we have to install the dampeners to reduce down the amplitude, because when earthquake comes, right, the building also will oscillate. The building will also oscillate. If somehow the earthquake matches the natural frequency of the building, then it topples. Okay, so same thing. There's a good for damping. Okay, to bring down the amplitude. No damping, there's good and bad also. Okay, so good side of it is that you don't have loss of energy. Okay, you don't have loss of energy. Okay, so in reality, most of the case we have damping. Okay, most of the case we have damping. For certain types of waves, is without damping. Now let me show you one animation. Last time I found very nice animation. Just to show you the okay, so this is without damping, so the wave looks like this. Okay, without damping. Now if I increase the damping, here at the bottom here I increase the damping. Okay, so you'll see the wave is exactly the same as what I just drew just now. Okay, so the wave like this. Initially is high, and then gradually it decreases in height. This is when there is loss of energy. Okay, loss of energy, damping. Okay, so that's on resonance, damping, natural frequency, free oscillation, and forced oscillation. Okay, so you should understand all of this phenomena. Okay, now next part, I'm going into the reflection of waves. Okay, reflection of waves 跟 reflection of light waves 是一样 concept. Okay, so for reflection of light waves, let's just recall a bit. So basically, you have a reflector. Okay, and light wave strikes it, and it forms a normal, right? So here you have a normal, and the laws of refraction states that the angle of incident is the same as the angle of reflection. Okay, now 只是唯一不同的就是在 light 你的在chapter light chapter 6，我们是当做 light 是一条直线 ，OK， 可是真正 light 是 wave 来的。So light is one of the electromagnetic waves. Okay, so what is electromagnetic waves? In case you don't know, that is all your microwave, gamma ray, X-ray, ultraviolet. So okay, those are the electromagnetic waves. Those are the waves that you cannot see. Okay, you have basically you have two types of waves. One is that you can see, another one is you cannot see. You can see, for example, water waves, ripples, or the waves through a spring or string. All right, the waves of a vibrating string, vibrating guitar strings. All the waves you can see. Okay, or maybe audience wave. There's such thing as the audience wave, the stadium wave stadium wave，就是当你在一个很大的 stadium 里面是有很多 audience imagine 第一排的人站起来，然后坐下来，第二排的人，第一排的人一坐下来呢，第二排的人就站起来坐下来。Okay, so this movement repeats. It repeats for the third row, fourth row, fifth row, sixth row, and following. Okay, just imagine, as soon as they sit down, the next row of people, they stand up and repeat the movement. So this one, if done perfectly, you can see the wave is like traveling to the back. If you're standing on the stage, okay, you're standing on the stage, you look at the audience, the wave is traveling from the front stage to the back stage. This is we call the stadium wave, the audience wave, stadium wave. This is also the wave that you can see, right? So waves that you cannot see, electromagnetic, light waves, radio waves, ultraviolet, gamma, X-ray, infrared. Okay, so all the EM waves that you cannot see. Now, doesn't matter if you cannot see or you can see or you cannot see. All of the waves they have one thing in common. They have one thing in common, and you should know this. One thing in common. What is it? Is that they all transfer energy, but not transfer matter. All right. So how do we describe a wave? A wave transfer energy. The disturbance is transferring. Okay. The movement is transferring, but not the particles. Okay. The particle never move. The particle will not be transferred. Only the energy is transferred. Let's take the same example as the stadium wave. The first row of audience, they don't go to the back row. They only stays at the first row. They just stand up and sit down. That's what they are doing. So treat each people as the particle. So the particle will not move to the back. Only the disturbance is moving, right? So that is what it means by the waves transfer energy, but it does not transfer matter. Okay, now, so reflection of waves, we are going to treat light waves as, we are going to treat light as waves instead of a straight line. Okay, now let me bring a picture up here. Okay, so you can see my screen. Okay, first look at the diagram on the left. So here you have plane waves. Plane waves 就是直直啦，直直这样子的 wave 不是圆的。So these are the plane waves. Okay, now again, this line shows what? 这种 line 是代表什么？这种 line 是代表 wave front. Okay, so back to 上次我们讲的那个 ripple tank. 你看这个 ripple tank, wave front 就是 OK， 上面我放一个 light bulb， 对不对？我放一个 light bulb， 然后它照下来嘛，然后它 form 一个影子在下面，对不对？那个是用来study 这个 water wave 的 movement water wave 的 movement。那我们讲拿到那种一线一线一线一线，就是当这个是 water surface， 给画好了。This is the water surface, right? So what happens? The light comes in. Okay, last time I talked about this, right? Treat the water waves, the surface of the water as a convex lens. 这个是 convex lens, convex lens, convex lens. And this one is also a convex lens. What happens is, if you have a bulb on top, when the water wave is moving, what happens is that the light passes through the water, and since it acts like a convex lens, 它会 converge 那个 light ray 去 one point. This one will also the same. It converges to one point, converge to one point, and same for the last one. So as a result, what do you see? You see one line black, one line bright color, one line black color, one line bright color, one line black color. 一线一线这样子. This is when you view from the top. So what is the line represent? What does the line represent? The line is the wave front. Okay, the line is the wave front. It's the crest. Okay, so this is your wave. The line is the point mark X over here. Here, here, here. Okay, distance between each line is the wavelength. Distance between each line is the wavelength. So the line is the wavefront. Okay. Now back to the image just now. Okay, so plane wave, 当它 strike 一个 reflector, it will be reflected. Now, it's the same concept as the law of reflection. Law of reflection 它讲什么 ？I 等于 R 对吗 ？I 等于 R， 所以我要讲找它的 I 跟 R 在这里，首先我要画一条direction line。OK， 所以当你做这种 reflection of wave 的时候，先画那个 direction line，the propagation line。So for this one, I draw my propagation line like this, the red line. Now be careful, the line that you draw has to be 90 degrees to the wavefront. So this is 90 degrees over here. 90 degrees to every wavefront. That is the propagation line, meaning that the direction of movement of the wave. Okay, so it's moving like here. Now as it strikes the point, this point, 这个 point 是 point of incidence 对吗 ？Okay, the striking point, the point of incidence. 然后我们画一个 normal line 是90度跟那个 reflector. Okay, like this. And then we work out the refracted line here. So you will find that the refraction direction is also perpendicular to all the wavefront here. Okay, so it's the same concept as the light, but the only difference is we draw the wavefront. Okay, we draw the wavefront. So this one line is one wavefront, the next line is the next wavefront. The distance between the line 就是那个 wavelength, is the wavelength. Okay, so this is for plane wave, reflection of a plane wave. So how about circular waves? Circular waves, you see here, it must come from a source, right? So this is the source over here. The source and the circular waves travels outward. Outward, spreading outward from the source. Now, as it hits the reflector, it reflects back. This is the reflected. Okay, let me draw it in red. So this reflected wave, if you connect all these reflected waves, 你会看到它 form 另外一个 circle 在对面。Okay, connect like this. You see that it forms another circle, and in the opposite, which does not exist. Okay, the region over here does not exist. 就很像a mirror, behind the mirror doesn't exist. Okay, so the region over here does not exist. But if you connect the lines, you will see that it forms exactly the same circle on the other side. This circle is exactly the same as this one. Okay, so image 你看这里也有写 image 对不对 ？image 是讲着那个对面的 circle 的中心点。image 的 position 是在对面的 circle 的 center。OK， object 就是我的 source 的 center。OK， now 你会发现到是这里有时 question 会问你what is the distance between the image and the object? So the distance between the image and the object, they are the same. Okay, they are the same. So I write it here. The distance from the center of the image to the reflector is the same as the distance between the source and the reflector, because the circles are the same, exactly the symmetry, not symmetry, exactly the same concentration. Okay, circle. Okay, so this is the one of the properties of the reflection of the waves, water waves. Okay, water waves. Now another example, reflection of wave. Oh, that's it. Okay, that one is wrong. Okay, reflection of wave 还有一个东西我漏了，就是只是方向会换罢了。Okay, only change in direction. Okay, so I write down here, change only the direction. So what is unchanged? Unchanged is first is the wavelength. Okay, so the wavelength will not change after the reflection. Also, the frequency will not change. Frequency. What else? The speed will not change. Does the amplitude change? Amplitude. Okay, amplitude 是它 depends 的。Okay, amplitude 它有时会变，有时不会变。它 depends on 你的 reflector 是什么。Okay, 它 depends on 你的 reflector 是什么。For circular wave on the right circular wave 它的 amplitude 是一定会变的。Okay, the amplitude for circular wave. Okay, write this down. The amplitude for circular wave, they will decrease. Okay, it doesn't matter what is the reflector, it will decrease for circular waves. For amplitude of plane waves, okay, it may or it may not change. It all depends on the reflector. Okay, that is for so amplitude may or may not change for a plane waves. But for circular, it definitely will change. All right, so take note of all these. So they will ask you in the exam, they will ask you, okay, what change and what doesn't change. Okay, all this for a reflection. Okay, now next one is you need to know how to sketch the reflection. Okay, how to sketch reflection of waves. So here, I'm going to show you how to sketch it. I have one example here. Okay, let's look at this. Okay, later this one 这个等下我会 send 给你，等下你试下 sketch. Okay, everybody you try sketch yourself after looking at. Okay, so now I'll teach you how to sketch it first. Then you sketch it yourself. Okay. Now first thing, you have a reflector. Okay, so 这个是你的 reflector， 这个是你的 incoming wave, and this line shows the wave front. 首先，你第一个步骤你要画你的 propagation 的 direction 在哪里 ？OK， 讲话，所以你拿出一把尺，看第一个线第一个 wave front 这边最远那个，找它的 midpoint。OK，let's say 我 mark 我的 midpoint somewhere here. Okay, your first step is to find a midpoint. The midpoint of the last wave. Okay, so this one we call the last wave. The first wave is approaching the reflector. Okay, so what you want to do is you find all the midpoints of each wavefront, and then you mark it, right? 其实你不用算全部了，你算只有一个，你算你找只有一个的 midpoint， 还有你找第一个的 midpoint。OK， 两个。过后你就 join the line, right? You join the line. Okay, let me do it like this. Okay, join the line like this. And this is the direction of propagation. Now remember, when you draw the line, you have to make sure it is perpendicular. Right? It has to be perpendicular. So this is the direction. Now here, what do you do next? 第二个步骤，你画你的 normal line， 这里 normal line， 然后你量你的 angle, incident angle I， 用 protector 量你的 incident angle， 然后你画你的 reflected direction. Okay, now in case 如果你没有 protector 这样，你可以这样子 ，OK， now let's say 我 extend 这个 normal 啊，我 extend 这个 normal。In case if you don't have a protector 啊，so what you do is you measure the distance here, okay, from this point 上面那个 x 啊，那个 x point 啊 ，the midpoint of the last wave, you measure the distance. Okay, what is the distance here? Okay, and then you make sure that this distance is the same as the distance here, and then you draw an x. So, okay, here. Again, you repeat the same for this one and this one. So you draw x here. Okay, so this is in case if you don't have a protector lah. If you have, of course, you straight away you measure the angle will be easier. Okay, so 量那个 x 的距离跟那个 normal. Okay, and then you find where is the x on the other side. Do it too, and then you join the line. Right after you mark the x, you join the line together. Join the line, and this shows the direction of propagation after the reflection. OK， 过后做什么？过后你就开始画你的第一个跟最后一个 wave。OK， 所以你的第一个 wave，make sure 你这个是90度，跟那个 direction of propagation， 然后它的长度也是不要相差太远啦。OK， 你可以大概画一样，不要突然间画一样短这样子。OK， 尽量跟对面一样。OK， 所以这个一定要90度。跟你的 propagation like this. Now I repeat the same for the last one, this one. Okay, this one put it here. Do the same, and then this also must be 90 degrees. Okay, next you have your first wave and your last wave. So what you want to do now is you complete the diagram. Okay, draw all the waves. Now be careful. One thing is 里面有多少条你就画多少条啦 ，OK， 不要突然间我们改它，所以里面这边有2个，我们就画2个，然后你也是要注意一下那个wave length 啊 ，the wave length 就是 distance between each line 啊 ，it has to be almost or it has to be the same or almost the same. Okay, the same or almost the same. So I write down here, not too much big difference, not too big difference. So this is how I sketch the reflection of waves. They will ask you to sketch, okay? They will ask you to sketch one. So you have to know how to sketch it. The reflection of the waves. Okay, 所以你可以量你的距离第一个到最后一个的 wave 是多少，然后你就除3个，那你就可以知道一个的 distance 是多少。OK， 我一直在 create 一个 link，almost time's up。